This video is going to be about linear functions, or more generically, lines. What do equations and graphs of lines look like? So let's start with talking about slope-intercept form, which is what most people are familiar with, y equals mx plus b, and point slope form, which is this y minus y1 equals m times x minus x1. And both of these forms are just different ways to write equations, and they both have their own purposes. So slope-intercept form is good for final answers. This is because there's only one way to write a line in slope-intercept form. Once you solve the equation for y, there's only one answer, which means that it's nice that there's no ambiguity about what line you're talking about. So when you're writing your final answer, we typically want it in slope-intercept form. Versus point-slope form, which is not as nice for final answers, because here this x1 and this y1 references any point on the line that you can plug in. So because there are infinitely many points on any line, there are a lot of ways to write an equation like this. However, this is good for something. In particular, it's good for building equations, because you only need one point on the line, and it can be any point on the line, okay, as opposed to this. So if you're not familiar, the m here in each case represents the slope, and in this case the b of this represents the intercept, the y-intercept of the line, and here x1 and x2 represent any point on the line. So if you want to go straight to y-intercept, to slope-intercept form, you're going to need the slope and the y-intercept. As opposed to point slope form, you're going to need the slope, because we always need the slope, but then you can just have literally any point on the line, which is nice for building equations, but then when we write our final answers, we want to use slope-intercept form. So hopefully you've already looked at a couple of examples in the textbook, but let's work one more. So write the equation and draw the graph of the line perpendicular to y equals 2x plus 1 that also passes through the point 2, 4. Okay, so the first thing is, anytime you're trying to find an equation for a line, you need the slope first. If the slope is not given explicitly in the problem, then the first step is always to find the slope. Now here, the way that we're going to get at our slope is we're given this equation for a line, y equals 2x plus 1, and this line has slope 2. Okay? And we know that our line is perpendicular to this line. So, if you've already looked at the book, you should know perpendicular means the lines cross in a right angle like this. Okay? So if this has slope 2, so I'll just say the original line has slope 2, and there's a very specific set of instructions that will tell you how to get our slope based on the fact that it's perpendicular. And that is, you want to take the opposite meaning flip the sign. So if it's positive, make it negative. If it's negative, make it positive. So this one is positive, so ours is going to be negative. And then you want to use the reciprocal of whatever this is. So this is 2, which means the reciprocal should be a half. And in case you're not familiar with the idea of reciprocal, when you take the reciprocal of a fraction, you just flip what's on the top and what's on the bottom. So this 2 is really like a 2 over 1, so if you want to flip that fraction, it's a 1 over 2. Okay, so here's our slope, negative 1/2. And now that we know the slope, and we know that it passes through some point on the line, we can use point slope form to build our equation. So we're going to use this equation, y minus y1 equals m times x minus x1, and we're just going to plug in the appropriate pieces to build our equation. Okay, so y minus, the y value of our point is 4, because remember y values always come second. And it's worth noting here, this minus sign and this minus sign are built into the equation. Okay, so you're always going to have those minuses, unless for some reason one of these numbers is negative, in which case you're going to have minus a negative, which will turn it into a positive number. Okay, so this does not mean that we are dealing with a negative 4. That minus is built into the equation. Okay, m represents slope, which we just decided the slope of our line was negative 1/2. And then x, and then x1, the x value of our point, is a 2. Okay, so the y and the x this y and this x, those are always just going to be there in the equation, because any equation of a line is going to have a y and an x, just like this one that we started with, y equals 2x plus 1, the one that our line is perpendicular with. So the only things you're going to plug in for are the slope and then the x and y value of some point on the line. Now this is the equation of the line in point-slope form, but in general we like to leave our final answers in slope-intercept form. So what that means is we need to solve this equation for y. So to do that, we're going to distribute this negative 1/2. So this is going to be negative 1/2 x and then plus 1, right? Negative 1/2 times negative 2 will give us a positive 1. And then we're going to move that 4 to the other side. So we're going to have to add 4 to both sides to get rid of that 4. So this is going to give us y equals negative 1/2 x, and then 1 plus 4 will be plus 5. Okay, so here's the equation of our line. And then we want to sketch a graph of it up here. And now, because we've written it in slope-intercept form, we know one point on our line, that's this. This gives us the y-coordinate of the y-intercept. So a y-intercept is the point that hits the y-axis, and so our line hits it at 5. So 1, 2, 3, 4, 5. This point is going to be on our line. And then we can use the slope to find another point. And in general, we think of slope as being rise over run. That's a sort of common way to think about slope. So we're supposed to rise negative 1 for our next point and then run 2 to the right. So we're going to go down 1 because it's negative, and then we'll go over 2, and here's another point on our line. So because we knew this one was on our line and the slope was negative 1/2, so that's down 1 to the right 2, here's another point on our line, and then because any 2 points determine a line, this is enough. So then we just sort of connect the dots, right? So this is going to be roughly what our line looks like. So you'll just have to use your imagination and imagine that that's a straight line. And a couple of comments. One, you always want to fill up the coordinate plane with your line. Don't stop short, don't just connect the dots. You want to sort of go for a while. And then you also want to put arrows on the end to indicate this line keeps going, right? It's not like this is the entire line. If we were able to zoom out, it would keep going forever in both directions. So here's the sketch, and here's the equation of the line.